Greetings and salutations, everybody. This is Jacob. Okay, so how the heck do we go about solving this problem? I can't wrap my head around it, you see. Well, let me say that this is one of those problems that are simpler than they look, my friends. Okay, let's look at our initial conditions. What does it say? What's the probability that one piece is attacking the other? Correct? What does that statement mean exactly? It means either the rook is attacking the knight or the knight is attacking the rook. Correct? So it's the union of these two possibilities in set theoretic terms. The intersection of these possibilities is null. In other words, it's empty, this intersection set, because they can't attack each other at the same time because of the nature of their movements is radically different. So let's start out with the rook attacking the knight. Let's look at this scenario first. What are all the possibilities of this scenario? So for argument's sake, let's drop the rook on a8. How many squares is it attacking? It's attacking 7 other squares on the a file and 7 other squares on the 8th rank. So 7 plus 7 equals 14. So there are 14 possibilities of the rook attacking the knight from a8. Likewise, if we drop the rook on a7, then the same holds true. It's attacking 14 other squares. In fact, on whatever square you drop it on, it's always attacking 14 squares. So the possibilities that the rook is attacking the knight are 64 times 14, which is 896 possibilities in total. So now let's look at the knight attacking the rook. Let's look at that scenario, which is a trickier scenario. Those darn knights, they're always tricky, aren't they? Just as in chess, they're tricky in mathematics as well, my friends. So why am I saying this? Because the number of squares the knight is attacking isn't fixed. Depends on the square it's occupying. A knight on the rim is dim, as some of you might be aware of this saying. So there are squares from which it only attacks 2 squares, and those are the corner squares. So the possibilities the knight is attacking the rook from the corner squares are 4 times 2 equals 8 possibilities. So now let's look at the squares from which the knight is attacking 3 squares. From a7, it's attacking 3 squares, correct? It's attacking c8, c6, and b5. The same holds true for b8. From there, it's attacking a6, c6, and d7. So there are 8 squares total from which it is attacking 3 squares. So the possibilities that the knight is attacking the rook from these squares are 8 times 3 equals 24 possibilities. So now let's look at the squares from which the knight attacks 4 squares. From a6, it attacks c7, b8, c5, and b4. Likewise, from a5, a4, and a3, it attacks 4 squares. And also from b7, it attacks 4 squares, and b2 as well. So from the left side, it attacks 4 squares from 10 squares, and 10 squares from the right side, for a total of 20 squares. So the possibilities that the knight is attacking the rook from these edge squares are 20 times 4 equals 80 possibilities. So now let's look at the squares that the knight attacks 6 squares. We'll call these squares the flank squares. From b6, the knight attacks c8, a8, d7, d5, c4, and a4. In fact, it attacks 6 squares from 4 squares of the b file, 4 from the f file, 4 from the 7th rank, and 4 from the 2nd rank. 16 squares in total. So the possibilities the knight is attacking the rook from these flank squares is 16 times 6 equals 96 possibilities. So now let's look at the rest of the squares, the center squares. The knight is clearly attacking 8 squares from these squares. It's living up to its full potential. Oh yes, as you see here. So 4 squares from each of the 4 center files, which is 16 squares total. So if we add up all these squares, there's 64 in total, so we're not missing any squares, my friends. So the possibilities the knight is attacking the rook from these center squares are 16 times 8 equals 128 possibilities. So to get the total number of possibilities the knight is attacking the rook, we just add up all these possibilities, and the total is 336 possibilities. So the total number of possibilities one piece is attacking the other are 896 plus 336 equals 1232 possibilities. So now to get the probability, we need the total amount of possibilities. The total amount of possibilities is 64 times 63, because dropping the rook on a random square and dropping the knight on a random square are what we call independent events, so we multiply the possibilities. Since the rook and the knight can't occupy the same square at the same time, it's 64 times 63, not 64 times 64. So 64 times 63 equals 4032 total possibilities. So the total probability that if we drop these two pieces on random squares, that one of them attacks the other is 1232 over 4032 times 100, which is approximately 30.55%. And that's your answer. 30.55. That's quite an intuitive answer, if you ask me. Wow, what a problem, you guys. Not a hard problem to figure out, just calculation intensive. Well, not intensive, but you know what I mean, my friends. It just requires you to list out and count all the distinct possibilities, as a typical probability puzzle would have you do. So let me know down in the comment section if you like this puzzle, if you found it hard, if you solved it in another way. As always, smash those buttons like there's no tomorrow. You know the drill, like your life depended on it. If you have a puzzle suggestion, then send it my way. I'm more than happy to showcase a puzzle you're fond of. That's pretty much it, my friends. I'll see you guys in the next video. Bye-bye.